Here I will consider with Easibex a problem of robotics, which is a range-only localization. So what is a range-only localization? I have a word, so it is the frame. In this frame, I consider one robot, say here, and this robot is as a position px and py, which is unknown. I have some landmarks, so the landmarks I will present now in black. First landmark, another landmark, and for the landmarks, I know the position. For instance, the position here, it will be, let's say, A of 1, the first landmark, the second landmark, and so on. And this one will be, let's say, AX of 1, AY of 1, and so on. Okay, so I know the position of the landmarks, and I am able to measure some distances to the landmark. So if you prefer, I will try to draw like this. If I measure the distance to the landmark A1, I know that I am on this circle, on this blue circle. I can do the same for A2, for A3. So I know that I am at the intersection of circles. But since these circles are unknown, in fact, I will. In fact, I will know that I belong to a circle with some uncertainty, which corresponds to a ring. Not exactly a circle, but a ring. So how can I do this localization? I will have to solve some equation, and this equation will be the following. I will have the following form. So for the first landmark, I will have x this square plus those corresponds to the norm of the vector which goes from P, the robot, to the landmarks, and this is equal to the distance d. So this is the case for all landmarks. So let's say for A belongs to 1, 2, and so on. So here I will have of A, AY, of I, and so on. So I will have many such equations that I want to solve. But recall that this one, the distance, is unknown, so I will only know that it belongs to the distance dA minus dA plus. Okay, this is the problem I want to solve with contractor programming, and here the tool I will use is Easibex. So Easibex, which is a tool to use some kind of interface, C++ interface, which makes me possible to use Ibex. So this is a tool for contractor programming. So contractor programming. So the Ibex is made by Gilles Chabert and a team such as Jordan Ninin, Fabrice Lebars, and so on. So I will develop this. To develop this, I will use a first CVA algorithm with first in, first out structure, a list. And I will start with this simple program. Here we have a separator, which corresponds to an inner and an outer contractor. And the main initialize vibes to draw boxes, and CVA, which is here, branch and bound algorithm, which will bisect boxes and will classify with respect to this separator. I have to start vibes. So vibes is now here. And if I run this program, which will communicate with vibes, I will obtain a set here, which corresponds to a ring. So this ring corresponds to the ring correspond to this separator. Okay. So let me come back here to recall what is a separator. If I have a set, let's say this set, a contractor takes as an input a box and returns as an output a box which the part of the part that has been removed by the contractor this part does not contain a single point of my set. So if you prefer, if my set here is X, if here I have a box X, then here I will have C of X, and what I can say is that the C of X intersected with X is equal to X intersected with X. So it means that the contractor C has not removed a single point of X. For the separator, it is, so most of the time when I want to use a CV algorithm, I will use an outer contractor, such as C, and an inner contractor that will be illustrated here. So the inner contractor only remove part of parts of the box that part of the box that are inside X. So most of the time I have to combine an inner and an outer contractor, and it is a separator. It depends of the value of the Boolean, which is in outer. If outer is equal to 1, I have an outer separator. Otherwise, I have an inner contractor. In the context of localization I want to consider here, I may have some outlier. For instance, if I measure a distance between the robot and A3, and this distance is wrong, I can represent like this. For instance, I measure something like 2 meters, but the actual distance is 10 meters. In such a case, I will say that I have an outlier and I want to take this into account to be robust. So, if I consider this, each measurement, in a general way, each measurement corresponds to one set. So if, for instance, this set corresponds to all position of the robot, which corresponds to one measurement. here another measurement, and here another measurement, and there the set of position will correspond to another measurement. If my robot is here, I am consistent with 3 sets. If I am here, I am consistent with two sets. So it means that here I have at least one outlier. So outlier. It means it is data which is not does not correspond to the reality. In such a case, I want to define the relaxed intersection. If I have x1 here, x2, x3, and x4, I define the so the intersection of all these sets is empty because I cannot belong to all these sets. But I define the intersection relaxed by 1 of all the xe, which corresponds to the set of points which belongs to all sets except one. So if you want, this corresponds to this. Okay. Now, in the same manner, I can define the set of all xe, which belongs to all sets except 2. So in this case, x2, so it corresponds to this, and also this. Because all green point belongs to 2 sets. Again, I can consider the intersection of all sets except 3 of them, and this will correspond to the union of these 4 sets. Okay. In such a case, how can I use contractor for this? I consider here 4 boxes, let's say with different colors. Uh, this color and okay, this this color. Okay, or maybe like this. So with boxes, I can also define the relaxed intersection, but the relaxed intersection will correspond to the smallest set, to the smallest box, which enclose all boxes except Q of them. So for instance, if I consider here the relaxed intersection relaxed by 1 of all these boxes, say xt, then I will obtain this box. If I define the relaxed intersection of 2 sets of all these xt, I will obtain this, and this also, and the set, if I want to obtain the set, I will obtain this orange box, and so. So thanks to I will be able to compute the inner and the outer contraction of relaxed intersection thanks to the counterpart of the relaxed intersection with contractors. That's what I can do, and I will illustrate it here. Uh, so let me come back to my problem. I have my CV algorithm, and I will have to define my landmarks. For this, I will consider a vector, so a vector of the landmark, so AX for the x axis, and it will be a vector of double. I will do the same just after, so for AY. AY. Now, I will consider a number of landmarks, so let's say int and landmarks, for instance, uh, 5 landmarks. And I will initialize these landmarks. So it's for int k equals 0, k is smaller than the number of landmarks, k plus plus, so it's the loop. And a pushback. Here I will take a random number. So rand give me an integer, and an integer, any integer. So I will take the modulo. For instance, if I want it to be between 0 and 10, I will do this. If I want it to be between 0, minus 20, minus 10, 10, I will do this, and I will remove 10. Okay. I will do the same for y, and there I have a landmark. I have my landmarks. I will use vibes to draw these landmarks. So draw, let's say, draw circle. I will enter here a x, or maybe okay, ay, okay, and I will draw them black. Black, and inside also black. Oh, I have several mistakes. Here should be inside. Should be inside. Here should be a string. What else? I run it. A mistake. Here an error. Or it is the radius of the circle I want to draw. Okay. So vibes gives me here the 5 landmarks. Okay. Now from these landmarks, before localization, I have to simulate the distances. So I will first have to give a position for my robot. Let's say Px, my robot is at the position, let's say 3.1, but I don't know this. And Py corresponds to, let's say, 5.7. It is the position of my robot. Now I will have to compute my distances. Vector double d of n marks. I will have 5 distances. For so I will take this one. The distance will be equal to, so the distance of k is equal to sqrt, so the square root of power, so the square power of px minus ax of k the square. So I am now writing this formula. Sorry. This formula in blue. I will have here plus power and we'll have and the square root. I will add the noise. The noise will be between, to take the noise, I will take, for instance, round. So this round will give me the smallest, the nearest integer. So it makes some noise. So when I have my distance, I will be able to maybe to draw my robot. I will draw my robot red. And at this level, I will be able to do my localization. Civia. And for my Civia, I will have to send the landmarks because I know where they are, AY, and the distances. But for my simulator, I will have to simulate some outliers. So how can I do this? I will consider a number of outliers. Okay, I will put this as a global variable, the number of landmarks here. And also I will take some outliers. The number of outliers or number of inliers is equivalent. The number of inliers will be those that are inside. I will take, for instance, 4. So this means that the number of outliers is equal to 5 minus 4, which corresponds to 1. So 1, I will generate one outlier. So for my simulation, how can I do this? I will do, for instance, something like for K1 minus n of inliers, and there I will take the distance of one data. I will take it randomly, random modulo the number of marks, and this instance I will make it uh, wrong. For instance, I will say that it is 10 meters. I could put something else. I have generated here outliers. So generation of outliers. And now I will be able to run my CVA. So this part corresponds to the simulator. What about the CVA? For the CVA, I will have to add it here as an input, the landmarks, which is known by the for the localization. So here AX, and the same for AY and for the distances. Here I will like this, go faster, the reference. So for the localization, I will take the CVA algorithm, but the only difference will be here. I will have AI, AX, AY, and the distance. Nothing else is changed in my algorithm. It will be a bisection algorithm, only the separator has to change. So the separator is here, and I will have to add all these parts. In my separator, I will generate a vector of box, which I will call y. Maybe I should explain why I have to do this. Oh, okay. So I have here several sets. This one, which corresponds to the first distance, let's say x1, another one, and another one. So in this case, they all intersect each other. I have my initial box. Let's say this box. Then I will contract it, this box, with respect to each set. So with respect to x1, with respect to x2, and with respect to x3. Here I have x3 and my set x2. So this box will correspond here to y to y1, excuse me, to y2. This one corresponds to y1, and this one to y3. So I have as many y than I have landmarks. Okay, so what I have to do first is to contract the box uh, X with respect to each set. I will generate uh, boxes and then I will perform the relax intersection. That's what I will do now. So the dimension of y will correspond to the number of landmarks, of marks. For all sets, int e equals 0 up to the number of marks, a plus plus, and I will initialize this box to x, and I will contract by this contractor S in ring, or it is given here. So copy paste. I will have here y, so I will contract the box y number e, the first component, the x component, the y component. Here I will have ax I, which is known, xy I, the distance, the if distance, plus the error. So the error will be, let's say, between minus 0.5 because I took the nearest integer. And here it will be the outer because I don't know if I want an inner. It depends, the value of outer depends if I take an inner or an outer contractor. Okay. So I have some problem with parentheses somewhere. Oops. Okay. I have generated all these boxes and I will call a separator which will be able to perform the relax intersection. Q in, which is inside this, so it is here. where I put the number of constraints to be satisfied, a list of box, the box I want to contract, and it is a separator, so I have to indicate if I want to contract with respect to the inside or with respect to outside. So here X, I will have the number of inlier Y, I need Y, this list, and outer. It is a Boolean value. Okay. Compile. Move. So here I miss some value when I call it. Probably here. I compile once more. Oh, I don't know where. Okay, yes. Px does not depend on k. Compile once more. Still some errors. Up, probably problem of parentheses. So probably here it's not x, it's y. I don't need these parentheses. Probably it was this. I run it once more. Uh, and I obtain here a pathing which encloses the true value for the position. Of course, here it is the position of the robot is represented by a big circle, but the center is inside the subpathing I obtain. So probably here I will put the circle smaller. Okay, if now I improve the number of marks, for instance, I put 10 marks or 20 marks, I can also improve the number of inliers. Let's say, for instance, 15 inliers. It means that I have 5 outliers. The 5 outliers are all the same. They are generated here. And the distance for each faulty sensor is given by 10 meters. So the faulty sensor gives 10 meters, but I could put something else. Okay. So I run it. And I obtain, so what is long is the compilation, it's not the resolution. And I obtain all my landmarks. Here, the position of my robot, which is here, and my subpathing. So it is reliable even if I have outliers. What it is important is that the actual number of outliers is is at least the one I assume. If I assume more, it's good. If I assume less, I am not guaranteed anymore. So I will illustrate it now. Here I assume 15 outliers. But assume that instead of 15 outliers, I assume 17, for instance. Then I will obtain probably the empty set because it is impossible to be consistent with 17 data. Indeed, I have no subpadding if I assume less, for instance, 13 instead of 15, then the subpadding will be bigger. But but it is still okay. Okay, so my subpadding, which is generated, which enclose the true value for my robot. Now, if I assume 10 outliers, the number will the set will increase. Or it is still okay. Uh, I will take more in order to illustrate. I will take, for instance, 5. I assume that I am consistent with 5. Then probably the set will be much bigger. Okay, so now I obtain this with plenty of different connected components because there is different way to fit with the data. In order to illustrate how the solution set change with respect to the number of estimated outlier, I will consider a new variable here is the estimation of the number of outlier. So I will call it like this, outlier hat like estimate. Here for the observer, I will have to put the estimate. Of course, we would like it to be equal to the exact number of outliers, but it is not always the case. And here, at the end, instead of calling CVI, I will make a loop, which will be, so I will initialize this as the number of marks. So it means at the beginning, I assume that I have no outliers. And I will do a loop for in k goes from 1 to k smaller than the number of marks. I will call Civia, but here I will change I will change the number uh, of inlier. And of course, I will have to clear the figure. So vibes clear figure. Okay, so that's all. And I will see how the solution set changes. there is an error. N marks should be like this. Hope the number of marks uh, so the set here moves. At the beginning it was an empty set, but at each time the number of inliers uh, is assumed to be smaller and smaller. Then I have more and more position for the robot, which becomes consistent. We can see the different shapes, uh, how they change with respect to to a small number of inlier. I have more and more solution, and each of them, each of the ring part of ring we can see is associated to one landmark. The last thing I would like to show is how the algorithm behaves when the marks are moving. So here I will assume, for instance, that I have exactly the same number of, so I know the number of inlier. Most of the time it's possible to find it because it is the largest number of I have to assume so that my set is not empty. Okay, so it is the principle of the algorithm Gomne, which try to maximize the number of estimated inlier. So I will consider this situation and I will make my marks moving. So I will remove this. Okay, so the number of inliers does not move anymore. Uh, and I will build moving, so to make moving target, moving marks. So here I will uh, make vector of double, and my mark will move with respect to some circles, let's say, with center Cx, Cy, the radius, so it will be maybe ellipsoid, Rx, Ry, so the radius with respect to A, radius with respect to Y, and maybe the speed of rotation with respect to this ellipsoid. Okay. I will take them randomly. So we'll do a similar loop as this. For all marks, I will consider a center and a radius. So I will have similar to that. I will have Cx. I will take a random number between, okay, like this one. So it is the center of the circle. Here for y. The radius for x will be like this, or x may be smaller, maybe 10, and the radius will be between 1 to 10, so like this. The same for y. And the speed of rotation . uh, omega pushback. So I will take a random number. Let's say 4 between or change -4 to 4. All these are integers because of this statement, random, which gives me an integer, and a modulo 8 to have something between 0 to 8, and because I remove 4, between -4 to 4. Okay, so now I will do my loop, which depends on the time. For t, t is time. So double, t start at 0, t is, let's say, smaller than 1, and t will move slowly like this. For example, it will be equal to t plus 0.01. So here it will be my main loop. Okay, now like this, maybe. Okay, so now I will clear the figure at this level. Vibes, uh, vibes. So it will be a clear figure. Then I have to build my moving landmark. So pushbacks, it will not be this anymore. It will be the center of the ellipsoid plus the radius multiplied by the cos of w of k times t. Here it will be the same for a. So here I will have y, radius with respect to y, and here it will be the sine. So maybe I should give some explanation here. The ellipsoid are considered for each mark. So consider, for instance, the mark uh, I will which corresponds to the is so the mark say a of e or k. I will have I want it to move with respect to one ellipsoid like this. For instance, this ellipsoid has a radius like this, which corresponds to Rx, and here it corresponds to Ry. The center here corresponds to Cx, Cy. So the equation of such an ellipse, I will have something which move like this. So this will be A of k, which will be my moving landmark. I will have A, so it depends of so A. This mark will depend of t on t, and it will be equal to C. So this one, C, plus, uh, so here I will have Rx cos omega t, Ry sine omega t. It is what I have implemented here. I can remove this and I can draw the marks. Now I will take a robot which move with respect to time. So what can I say? I can say something like moving with one circle or a Lissajous curve. So I will consider this one, for instance. And for Py, I will have 1 plus 4 times cosine of 2 times t. So the frequency is different to make it moving inside the region corresponding to the box I have taken. Now, uh, now I will draw the circle for the robot and compute my distances. My distances are given here, nothing changed. I will generate some outliers here. And I will call Civia there. Okay, so I run it. So what can I see? Here, I can see that I have a pathing which contains a true value for the robot. So, okay. So of course I should have taken better precision, but we can see that it is quite accurate even if I have outliers. If I want a better accuracy in the Civia, I can change, but of course it will slow down the computation. So if I put, for instance, 3 like this, I run it, it compiles. So we can see that it takes much more time to compute, but my robot is always inside the set I am computing. And this is due to the fact that I am guaranteed if the number of outliers I assume is exactly the same as the number of existing inlier. So if the estimation is smaller than the actual one, then I will obtain a guaranteed result.